Well, I'm full of sugar and tahini and beeswax and coconut oil, so I'm full of it at the moment, and thus I am ripping and roaring and ready to talk. Now, a little aside here: some people think I talk too much, but they just don't want me to reveal anything, and they like to use the excuse that I don't have any letters behind my name to vouch for vouch for your safety as a guarantee to listen to me. But of course, that's very old school, because in the future, as Alvin Toffler has said in his book Future Shock, which my stepfather read, and I started to read it after he got done with it. The future is not a future of institutions. The future is a future of cottage industries, something Gandhi would approve of, but has been very long in acceptance. People are still into big is beautiful, but in reality, small is beautiful. And we'll have to help each other in our small communities, because the big metropolises of our day won't be around to help us out in the security of numbers. So I take that point of view, and I try to spread things around for free and just work on things to try to help myself along with anybody who's willing to listen. And it shouldn't be depressing that very few would bother to take the trouble to listen, because the way things have been projected by Charlie Lutz, there won't be a whole lot of people to pay attention, even if they all wanted to, let alone a small percentage. It'll be a different percentage in the future, but it will be about the same numbers, really, is what it is. And interestingly enough, Charlie Lutz specifically said 4% of the population will survive. He didn't put those words. He said 1 in 26. And if you do the math, it's around 4%. And it turns out that on some website, somebody had found someone or something had relayed the information that the powers that be, who want to create a new world order, have decided to wipe out the other 96% of the population one way or another. So, starting off on a very sour note here. I better slow this down. It's jumping too much. This actually, without the taping session, it runs more smoothly. And I'm a very impatient fellow, and so I work hard and fast, and I like to run my simulators fast if I can, but I can't always. But I like smoothness. So you can tell if the electrons move around here nice and smoothly that your simulator speed is not overshooting the resources of your computer. Anyway, we'll just turn it down real slow here. So I wrote a little piece, and I keep adding to it at Energetic Forum, and the shortcut is is.gd/DIVCON, as in divide and conquer, the mystery of free energy. And it basically has to do with reusing voltage rather than draining voltage, and draining current, not voltage. Because current you can always get again and again from the same source. No matter how much you take away, there's the magnetic field of the source of current is always there. It never goes away. I mean, that's the beauty of current. Its source is the magnetic field, and magnetic fields don't alter their characteristic intensity due to our use of them. They alter their characteristic intensity due to time taking its toll on the materials of construction or whatever it is that's producing that magnetic field. It's the time, the dynamics of time, that wears down a magnetic field if it's not being renewed one way or another, structurally renewed. Because ultimately, one might argue, of course, that, magnetism, the chicken and the egg syndrome, magnetism came before material substance. But, I prefer to stick with concrete reality, and concrete reality creates magnetic fields and not the other way around. So that, at least from our perspective, we have to do it that way. We don't know any other, let's put it that way. So When we construct so when we go about it, we construct the material design of the device first that will then create as its effect or benefit, as its side benefit, a magnetic field. And it's the decomposition or degradation of that concrete device that will in turn signal the end or the slow demise, actually, the slow demise of the magnetic field that device produces. So, but aside from that, it's not related to use. Magnetism is not something we consume, and voltage is something we can reuse. We don't consume that either. So there's nothing about electricity that's a consumable product. Unlike wood, you put in a fire and you consume it, and you're left with ashes that you can't burn. But electricity doesn't work that way. It's a composition of magnetism and electrostatic voltage charge, and the varying of that voltage charge that causes the magnetism to induce within itself the synthesis of more current. And so it's very easy to tweak magnetism by the use of a changing electrostatic field to get it to give us amperage over and over and over again. And that's what I do in this circuit. It's so simple. Unlike, all my other circuits that tend to be complicated. This one is thematically simple, but it requires intelligence on the part of the user to operate it, so I decided to put in instructions. It's not good enough to have a video, because you may not go find the video, and the video may even be dropped from YouTube, so it's much better to just include the directions with the circuit. And look how many parts there are. You got 2 capacitors, 3 batteries, 2 switches, a coil load, an inductive load. What else? 3 resistors, 2 antenna, and some wire. Did I say, yeah, 3 resistors. And then the instruction set of how to run it. So you have to have like a computer chip or something running this thing, or yourself. And this is the way I think Tesla went about his Pierce Arrow demonstration. It was very rinky-dink, like almost off the cuff. Nothing like his prior work that had, rivaled an engineer's dream in terms of proficiency. And the automobile really lends itself to a rinky-dink, quick throw-something-together setup, because in those days there were no car computers to regulate anything. And so anything that could be done without the regulation of a computer, which didn't exist then yet, was simply operated by the individual. So everything on the radio was manually operated by the individual. There was nothing inside to contribute to the operation or the operational management of that radio. There was just a few dials and buttons, and it was all up to the user to make the radio happen. And that's where, came the notion that if something doesn't work, slap it a few times, maybe it'll work, because there was very limited interaction between the user and his device, and the device was too dumb to do anything on its own without any help from the user making it do stuff, like turn on, for that matter. You turn the switch. So I think that's the approach I've always thought, and I've never said this, and I think it demands saying now, because that's the way the circuit runs, and the way it's designed to run, is that the user has to see to it that his skillfulness as a driver operating the vehicle, he knows exactly what he's doing, slightly different than what he would normally do. Because in order to accelerate this thing, you don't just push on the foot pedal to make it go faster. Now, unless, in this example, unless Tesla did something in addition to the circuit that was maybe mechanical, in addition to the electrical component, that would do what I'm saying I have to do manually myself, and that is, if I want to accelerate the power base for the circuit, if it runs down too much, I have to disengage this power circuit from the load coil over here by opening this switch before I toggle the value of this capacitor up and down in order to get it to create a varying electrostatic field, so that its interaction with the coil here, the transformer pair of coils, can produce more power, actually more amperage. And it'll produce it over here on the left side of the transformer, coming from the aerials. But I found something interesting though. I lowered the coupling coefficient of this transformer to 0.1, because if I raise it to 0.999, it doesn't work very well. All the power gets lumped on the left side of the transformer, and there's much less for the load to enjoy on the right side. And so truly this transformer is an isolation device, isolating the two halves of this circuit. And so this capacitor is a regulator in a sense, because it instructs the left side to produce more amperage. And it also is tied in with this load, but only if the switch is engaged. You see, right now this load is shorting out this controller, which is okay for running mode. But for amplification mode, the load has to be disengaged before we escalate the power on the left-hand side. But as you'll see down here, most of the power is on the right side and very little on the left, and all because of the low coupling coefficient of 0.1. Now, slightly arbitrarily, but I think it also for common sense purposes, I made the transformer, the two coils of each of the two coils of the transformer rated at 2 henries of inductance, which is exactly the same as what I have the motor coil in its entirety rated as, represented by this single inductor. And I think it's a pretty good idea that when you're trying to tell this capacitor here to raise the power over here in the transformer, it's going to be used by this inductor over here, which is the load. Now I've separated it. In my proof of concept, I made believe that the transformer was acting as simulating a pair of motor coils. But I realized I couldn't get the voltage up. The voltage was extremely low. And the only way to get the voltage up was to add another coil to serve as the load and move it over here to the right, tied in directly or immediately with this controlling capacitor, but also add another capacitor over here on the left of a slightly smaller value, and split the battery pack and put it on either side, because I made a video and it's, where is it? Oh, I don't put it here. Oh, because I figure when you go to DivCon, you'll see the shortcut for the video. I'll show you what the DivCon goes to, so that you get an idea what it looks like. So it goes to this post that I made, and I keep adding to it, and I even added an attachment, a screenshot of what my present work. But this is the prior work. See, so there's no capacitor or battery pack, the battery pack of the EV over here on the left. So I added all that, but pretty much kept everything else somewhat the same. Oh, and then I added the load on the outside here. What was I going to say? Oh, so the cap bat. Where is it? Here it is. It's a video, and although there's nothing indecent about the video,
to you that whether or not they
some people would be offended by a lack of shirt.
Just because they come as a matter of inspiration, and
anyway,
I'm not really
this guy really liked it. He said, very astute observations, very correct in contrarian convictions.
So
thank you for posting.
Here's my latest.
Isn't that nice of him? Very nice of him.
In considering the alternative story
this is
of
where I
Tesla's
introduced the
Pierce-Arrow
idea
demonstration of
that we could take...
1931.
I'm sorry, I didn't realize he's talking and interrupting me there. See, so because I have my speakers off, so I can't hear him, but you hear him, and that's a boo-boo. I'm sorry. So what I'm mentioning there with my yellow headband is that if we take a capacitor, and instead of putting the same plate on either side, made of the same material, let's say aluminum electroplated to either side of glass, a very thin plate of glass, then it's going to behave like a capacitor. But if we choose two metallic substances that have a difference between them of their electronegativity, then it might just function similar to a battery, but not the same, because it won't allow current to flow through it. Instead, it will prevent current from flowing through it, and it will instead function like a capacitor that's pre-charged, in a sense, without really having any charge, because it won't have a pre-charge to lose, to discharge the pre-charge. It simply remakes the voltage all the time, due to the fact that, like the zinc and copper on either side of the mica, thin film mica separating them, is always creating a voltage difference. And Thomas Beard said, don't kill the dipole, but he never said how. How is you don't take any current from it, or in the case of John Bedini, you take current from it, but you don't return current that you took back to it. But I'm trying not to take any current from it, at least in concept. But what I did here is I tried to do the same thing, and it seems to help, especially if I raise the voltage a little. Initially I had 72 volts, one half of the battery pack on one side, and another 72 volt battery half on the other battery pack half. For a 144 volt battery pack of Greg Tuntlin. But my car, it's a 350 volt battery pack. But that's only when it's fully charged, which doesn't last very long. So if I take the supposition, 80%, it might be 250 volts. Anyway, I did 108, so it's 216 volts total surrounding this capacitor. And it works like a charm, and it makes sense because it's on the other side of the transformer. See, it oddly enough, whatever happens on one side of the transformer has direct impact on the opposite side. When the two sides are interacting to create more current. I'm not creating more energy, I'm creating more current, but I'm trying to reuse the voltage. But I had to get the voltage up. And so I used these two techniques of separating the load from the transformer and putting it in line with the commanding capacitor, and then putting this triple layer, sandwich layer of battery, capacitor, battery on the side opposite, on the side of the transformer opposite to the load and controlling capacitor, on the same side as the two antennas, and that worked like a charm. So I added all these instructions, and that's for starting it from a cold start. But I decided not to post a cold start because I thought it would be too complicated for somebody to worry about. Sorry, just excuse me. So instead, I just let you read about it, what you would have to do in order to do it from a cold start, and it is a lot of work. Instead, I just decided to post a pre-charged version. Now, having a coupling coefficient of 0.1 slows down the dissipation of charge on from both sides. And it also tends to lump all the energy on the right-hand side rather than on the left. And I suspect it's this arrangement over here that helps to do that as well. But if I had a 0.999, I just wouldn't be able to get the effects that I've been getting. And now, I started out with 0.5 yesterday when I did my proof of concept. But when I did this fully developed version, I decided to go up to 0.999. I made it worse, so then I decided, maybe I should go in the opposite direction. So I made a 0.1, and it was even better. It's the best of all. So I have what I want. I've got 200 amps on my inductive load, and my the aerial is 36.5 amps. So what I do when I jiggle this up and down, the value of the capacitance of this controlling capacitor, I look here at the aerial. This is the top aerial that I've scoped, and I watch for 60 amps, because that will around 60, some of the time, will give me 200 amps over on the load. This is a very rinky-dink circuit. It's in the sense that it's kind of haphazard. You never know from one time to the next what you'll exactly get. And it could be more or it could be less. So I did the best I could, given my simple brain and my need to keep things simple as well, because I don't, over time you can always make something more complicated. Trust me, it works with everything. Like a recipe for a cake. You just put flour and sugar and oil together and water, and it'll be cake. But if you keep doing it over and over again, you start adding and changing, and before you know it, you get a very complicated recipe, and it comes out really exquisite. But in the beginning, it never starts out that way, and so beginnings are always simple. And I better stop this. Beginnings are always simple, and so you have to, be a bit tolerant for simple beginnings. Now, this is the shortcut for this circuit: SYNCUR, synthesis, synthetic current, because that's what we're doing. And actually, that's a funny way to put it. Synthetic current? Is there such a thing as real current? Well, no, apparently not. It's all synthetic. It's all synthesized. Now, this link over Unity, that one goes to a web page in which I list all of my circuits that still work as over Unity devices in the real simulator of equivalent series resistance of caps and coils, as opposed to this simulator, which doesn't have that built into caps and coils. I think I've already tested this on this and its prior prototype on the realistic simulator, and it works just as well on both. In fact, I think it works even a little better. Some circuits actually work a little better when they have equivalent series resistance inside their caps and coils. What else? So that's what this over Unity, but I haven't put the circuit on that list yet. I've been too busy working on this circuit to be able to do everything that I want to do. It's taking a few days to do everything. I wanted to do a good job on this circuit because I know how important it is. For me, it's like a breakthrough in my learning process, of self-learning process, of teaching myself what Eric Dollard and, people like him talk about, having done themselves. I don't expect to be able to do it myself, although I love to dream, and this is part of my dreaming process. And this lends a little firm foundation to that dreaming process because it's a little bit more stylized, or maybe not stylized is the word, detailed. And I get to not blame the simulator if you don't like what if it doesn't look realistic, or if you tried to build it and it didn't work. But it's better than nothing. Let's put it that way. I have no other option. This is pretty much it. It's free. All it requires is my time and devotion. So I got a 12-step program here of from a cold start, how to get this thing going to where you want it to get to. Unfortunately, a lot of my circuits, all I know how to do is to build up energy. I don't know how to reduce it or drain it or turn it off. I mean, right now I turn the simulator off, but well, let's see. See, if you throw this switch, then the load is turned off. But that's not to say that the rest of the circuit is turned off. The rest of the circuit is busy humming like crazy, and this switch is merely to get it going from a cold start with the help of this little 6-volt battery. So I really don't know of any way to turn this thing off. See? We get back about the same amount, 213 amps, as we had before. So it doesn't go away, it just keeps recirculating in here. Let's see, what else should I cover? Let's see. Well, I don't know, you have to read this. I can't remember what I put in there. Yeah, it's a lot of work me doing this stuff because I have multiple websites I got to post and keep each one up to date. And then these photographs, snapshots, and whatnot, the circuits themselves. But anyway, it's fun. It keeps me busy. It keeps me positive-minded. And I have to really credit the guy who turned me on to Cyril Aman, because that made all the difference in me being inspired. The use of two aerials and wind or air flowing between them at a perpendicular to maintain a separation between them, a capacitive separation. So that was the other idea, now that I think of it, why I put this here. I wanted to put a capacitor over here to no longer just consider that this airspace is a virtual capacitance going on. I wanted a real capacitance, but something different than over here, because, you know, if I just put another capacitor here, it doesn't really do anything. So this sandwich of battery, capacitor, battery did the job. It actually does the job, and I don't monkey with it. You know, and once I set it up and I leave it there. The only thing I monkey with is this value of this capacitor here. You know, a lot of people will go, oh, how come you don't put a potentiometer in there? It doesn't work. The whole trick here is to varying capacitance in the circuit, varying the electric field in the circuit, the electrostatic charge in the circuit, not its resistance. The only time I vary resistance is when I open and close a switch. And that's it. And of course, if we're driving this as an EV, again, driving it will cause air to flow here and increase the resistance between these two antennae. Other than that, I don't monkey with resistance, because it normally, in terms, you know, I got started with Eric Dollard's analog computer, and resistance doesn't play a role. It plays no part in the behavior of that analog computer. At least, you know, the standard version that, you know, he gave to all of us, not some of the more arcane ones that some of which he keeps to himself. You know, the two capacitors on either side of a square-shaped module, and then the other two sides of that square is two coils. So I like to use transformer as my two coils, because for some reason an air core coil just doesn't work. But if it's, and in fact, if you watch the videos from see, now there's a link I don't have here. It's is.gd/ANA. Oh, what is it? ANA? Whoops. Anacomp? I think it's Anacomp for analog computer. Let's see, where is it? Electricity can be synthesized. Here we go. Anacomp. That's it. Yeah, so this is the link. And this goes to a video, and Borderlands video. Oh shit. Sorry. Transverse and longitudinal electric waves, Eric Dollard and Tom Brown, put up by Thomas Joseph Brown. So this, this answers the question, what is an analog computer? And literally, I think they say that in the video. So they answer the question. Let's see if I can make it big for you. Whoops. Oh, that's too much junk. I keep forgetting when that happens. There. So there it is. is.gd/Anacomp. And that takes you to answer the question, what is an analog computer? Well, it's constructed of two caps and two coils. So from that beginning, I learned that resistors don't play any role at all. I mean, in terms of the thematic content of that concept, that electrical concept. And although I don't, strictly speaking, use that concept anymore, although it does color all my work, because I use caps and coils, because it works. It's a skill. It started out as a skill building exercise to train me what to look for and what to focus on, and as primary relevance, and everything else is secondary, if included at all. And so you don't see a lot of things, like you don't see any spark gaps in here, do you? You know, spark gaps, you know, we can say a lot of nice things about them, but they're just an enhancement tool. They're not a requirement. And I suspect they enhance because they vary electrostatic charge in the circuit, but in a randomized fashion. And I don't need that. Not in this circuit. I need something that I can control, because Well, it's an EV. You have to have an EV. You have to be a stickler for control if you're designing anything for intended to be used in a car, because safety first, right? We want the car to do what we want it to do and not do something at random. Yet this circuit is a bit random in its behavior. So it's not the ideal, certainly, but it's a first attempt, or second attempt actually, at constructing an over-unity device intended for the car and satisfy the various questions I have in, what is Tesla's Pierce Arrow, what is Sierra Lemone's EV, and how do we apply what Eric Dollard tells us is the synthesis of electricity, which I suspect Joseph Newman has already done in his device, the blending of electrostatics and magnetics over time. So that's what I think I've done in my own simple-minded way, in my own unique way. And I guess I'm a little proud, or else I wouldn't talk so much. But I really think, to me, it's an important breakthrough because of its simplicity, its practicality, buildability in terms of there's nothing exotic going on here. Whether or not you'll get the same results, that's something else. But it's, not using difficult to, maybe one component. You have to be able to vary the value of this capacitor within the range of a little more than 1,000 to 1 of its capacitance. Well, in this case, it's 50,000 to 1. So, if you can find a vacuum tube variable capacitor that can have its capacitance varied by 50,000 to 1, then and in which its minimum is millifarad and its maximum is 50 farad, then you can put it right in here. Otherwise, everything else is not exotic. So it has one exotic component. Yeah, I guess every time I make a circuit, there's always something exotic about it. Yeah, I'm always pushing the envelope. Okay, I got to admit it. I'm not normal. I'm not conventional, as the guy said, commented on my YouTube video. All right, so that's enough said, and I will now sign off.